Hello, we at Baseline Technologies welcome you to this presentation on vibration and its applications. In this presentation, we will discuss why vibration is important to you as a plant engineer and how you can apply it to reduce sudden plant breakdowns and also lower energy costs. Lastly, we would like to introduce to you our products which are designed to solve some of the problems that we would have discussed in this presentation. Baseline Technologies, based in New Delhi, has been offering contemporary instruments for measurement, analysis, and monitoring of vibration and sound in India since the last 25 years. It was set up in 1990 by highly qualified and specialist engineers from IIT and continues to specialize in the above areas with no dilution in focus. Baseline Technologies has over 3,000 users today. It has supplied its instruments to almost every segment of the Indian industry, including the nuclear power sector, railways, and almost every leading engineering industry in the private sector. It is considered the market leader in its segment in India. These instruments have achieved industry leader status over the years due to their quality, dependability, ease of use, and continued application support offered by Baseline. Vibration is simply the to and fro movement of a body around its rest position. Vibration can be categorized into two major types: random and periodic. Random vibration lasts only for a short while as a response to a random event. For example, bridges, railway tracks, and other structures like buildings responding to transient events and seismic phenomena. Here are some examples of random vibration, which is also sometimes referred to as stochastic vibration. Periodic vibration is a steady movement of the body around its mean position. It is a repetitive, predictable phenomenon and has a specific period over which it repeats itself. It is always a response to an alternating force. For example, machinery vibrations and also structural vibrations caused by gensets or air conditioning plants, etc. Such vibration displays a periodic time function which follows well-defined mathematical rules like a sine wave or the sum of many sine waves. It can thus be reasonably predicted. Thus, the concepts of frequency and its inverse, the time period, are associated with periodic vibrations. Baseline offers equipment for assessment of the second type, that is, periodic vibration only. Here are some examples of machines which display periodic vibrations. Vibration occurs in every rotating or reciprocating machinery as a consequence of forces which are generated in such machines. These could be due to a variety of causes, such as rotor imbalance, misalignment, faulty bearings or gears, eddy currents, electromagnetic forces, etc. These forces act through the bearings to move the stationary parts of the machine. If these forces are left unchecked, the following consequences are to be expected. Metal fatigue leading to fracture, a lower bearing life, unexpected plant shutdowns. Energy wastage due to kinetic energy required for vibration. One of our customers confirmed having saved up to 18% of electric energy costs by implementing an effective plant-wide vibration control program. Operator fatigue and nuisance, which have occupational health consequences. Also, in some machines, it directly influences product quality. For example, in grinding machines. Here is a real-life example. A cold rolling steel strip manufacturer was not able to achieve perfectly finished sheets. The problem was found to be the vibration on the grinding machine which was used to grind the rollers. This company managed to control the level of the vibration on the roll grinding machine to extremely low levels. This resulted in an additional price of 25% due to higher quality classification based on the finish of the rolled sheets. All vibration is the to and fro movement of a body around a mean or resting position. It can be measured in various ways. The amount of movement or the magnitude is known as displacement. It is the distance moved from one end to the other and is referred to as peak-to-peak displacement. The typical metric units of displacement are microns. Displacement emphasizes low-frequency vibrations. It used to be a popular method of measurement some 50 years ago. However, it does not convey the complete picture since the energy of vibration is not only how much of the movement is there, but also how fast it is moving. The rate of change of displacement is velocity. It is the first differential of displacement with time. Therefore, velocity is the most commonly measured parameter as per modern standards. Velocity is the best representative of the energy of vibration. Velocity factors in both displacement as well as frequency. The metric units of velocity are millimeters per second. Velocity places even emphasis on low and high frequencies of vibration. The rate of change of velocity is acceleration. This is the second differential of displacement over time. The metric units of acceleration are meters per second squared. Sometimes this is also expressed in terms of the gravitational constant g, which is equal to 9.8 meters per second squared. Acceleration emphasizes high frequencies and de-emphasizes low frequencies. Unless specific standards for specific industry apply, the guidelines given in IS 11724 are a good guide for assessment of vibration severity on rotating and reciprocating machinery, which runs between 600 and 12,000 RPM. The standard is identical to globally employed standard ISO 2372. In essence, the standard specifies how and what to measure and also classifies various types of machines into different categories depending upon their size and foundations. It then lays down relative quality grades depending upon the measurement of vibration velocity. It also emphasizes the use of true root mean square velocity as the preferred parameter for severity assessment, as this is the only parameter which represents energy in the vibration correctly. However, it does not mandate any acceptability criteria and leaves that to the discretion of the user. This is where the experience of the maintenance manager comes in. It is essential to periodically track the vibration severity as measured by velocity in millimeters per second true RMS at specified points on the machine. This provides valuable insights into whether a quality level B is good or C is acceptable for a given machine. It is our experience that uncontrolled levels of vibration in the Indian context normally hover around C to D levels, and it takes conscious efforts to get these to stay within B levels. It is also our experience that levels controlled to B levels or better actually result in significant reduction of breakdowns and bearing replacement costs. It must also be mentioned that in vibration, the normal range of accuracy is plus minus 10%. Since a lot of factors affect the vibrations, such accuracy levels are considered adequate internationally. The action points normally occur at a change of 50% or more in vibration levels at the same point on a given machine. There can be several causes for vibration in a machine, and each cause has its own specific frequency. Thus, causes of vibration are identified through the understanding of frequencies present in a machine. Based upon our experience, we find that imbalance is the number one cause for vibrations in rotating machinery. Whereas in most cases, imbalance can be controlled by simple field balancing techniques, there are some cases where balancing does not seem to work very effectively. Such cases often pose a challenge to the engineers and may require the services of outside experts, and yet sometimes the solutions can be amazingly simple. Amongst other common causes are misalignment, faulty couplings, vane pass. In pumps and blowers, the fluid going through pressure variations around a vane is often a source of eddies. The vibration can only be controlled by good design. Faulty bearings. These are often the source of high-frequency vibrations in rotating machinery. Electrical motors may also exhibit vibrations due to an imbalanced or saturating stator field, which creates a distorted rotating field. Such vibration normally occurs at the electrical frequency or its odd harmonics. If the motor is also mechanically imbalanced, then the phenomenon of beats at the slip frequency is often observed. A very simple form of monitoring vibration levels in machinery is to maintain a trend chart of vibration. In this chart, overall vibration velocity or bearing-related vibration levels are plotted over time, and the trend can help draw valuable conclusions regarding preventive maintenance. In most cases, the technique of frequency analysis of vibration, also known as spectrum analysis, is essential to get to the root cause of the vibration. This technique is based on the fundamental concept that if there is a vibration at a certain frequency, its cause must also be at the same frequency. Thus, frequency information of the vibration is essential to fault finding. A wealth of information exists on the internet and otherwise on interpreting the results of frequency analysis. Further, a system of periodic vibration assessment offers a powerful tool in the hands of a maintenance manager. A simple form of this is a systematic collection of vibration spectra at periodic intervals on specified points on critical machinery. Techniques such as spectral enveloping and trending are invaluable for keeping a check on vibration and also in effectively preventing breakdowns in a plant. Unbalance causes centrifugal forces in a machine. These forces create vibration at the rotational frequency. The principle of in situ balancing of rotors is based on this simple premise. We measure the vibration as a vector, that is, amount and angle. The amount is proportional to the magnitude of unbalance, and the angle is proportional to its angular location on the rotor. A known unbalance is introduced and the system response is calibrated. The process then yields the correction mass to be added to counter the original unbalance. Field balancing or in situ balancing is the process of balancing the rotor by running it in its native assembly with its own power. There are some field balancing instruments which simply give the vibration vector, and there are other instruments which do the entire computation and provide the exact result of where and how much mass is to be added to balance a rotor. The benefits of vibration control and vibration-based condition monitoring are obvious, to say the least. Longer mechanical life of machines. Lower bearing replacement costs. Lower energy wasted. Better predictability of potential problems. Better quality of output. Quieter and less fatiguing environment. Reduction in unscheduled breakdowns. The cost of instrumentation and development of in-house expertise is often recovered in one single breakdown prevented by these. Payoffs are often immediate. The long-term benefits are huge. This is the reason why most process plants find this to be an extremely rewarding investment. Baseline offers instruments for measurement of vibration. There are two models of vibration meters, 2050 and 2040. Both are considered industry leaders in the segment and are in wide use across a range of industries. For frequency analysis, we offer the Vibration Analyzer 6050, which also combines with it the software VS22 for the PC. With this instrument, one can set up a fairly sophisticated condition monitoring system in one's plant. It also provides the option of in situ balancing of rotors and continues to be one of the most preferred instruments by service providers. There are three options available which provide in situ dynamic balancing function: the 1000D, the 6050, and the 5200. The portable balancer 1000D has been mandated by the Indian Railways for balancing of blowers on the electric locos. This unit operates on the conventional stroboscopic angle principle and does not offer any vector computations. The 6050 offers vector computations also in addition to vibration analysis. The latest addition, the 5200, is a versatile balancer with many options of balancing and is a professional's dream. With its advanced digital signal processing, it offers unmatched precision and an optional printer to document the process. Some features of the vibration meters 2040 and 2050 are shown in this slide. Features of the vibration analyzer cum dynamic balancer 6050 are given here. The ever-popular portable balancer 1000D is described here in brief. Some details of the portable balancer 5200, our latest product, are given in this slide. Thank you for your precious time. We hope to hear from you in the near future.